we are all now familiar with the trigonometric functions, but how could we practically use them and deduce them from specific sets of given? Well, today's lesson will answer just that, but before we start, let's quickly review the trigonometric lines. The trigonometric functions that we are going to use today are cosine, sine, tangent, and cotangent. Remember that they can only be applied in a right triangle. Now that we have reviewed the trigonometric functions that we are going to use today, let's identify how to use them to locate a point in a trigonometric circle. Let's consider a point A on a trigonometric circle of origin B. If we form a right triangle called AOK, we can notice that OA, the hypotenuse, is equal to the radius 1. Now we can form the equations for the sine and cosine with respect to angle O, and we will notice that since the hypotenuse is equal to 1, both sine and cosine are equal to the sides AK and OK respectively, which are also the y of A and x of A. We can conclude from the above that in a trigonometric circle, when we are given the trigonometric functions, the sine and cosine of the central angle with respect to a point on the circle, we can find its exact position, where sine is the ordinate while cosine is the abscissa of that point. Surely, if given the coordinates of that point, we can also calculate the angle and of course deduce the sine, cosine, and all other trigonometric functions. This leads us to another point, which is the signs of these functions, because as the angle varies, the function's values will change too, and along with them is their signs. Therefore, it's easier for us to divide the circle into 4 quadrants, where in each, no matter where the point is placed, the sign of the trigonometric functions will stay constant. Now, if we view a trigonometric circle, we notice that in the first quadrant, both coordinates are positive, where their values are between 0 and 1 on the axis, and therefore all previously mentioned functions are going to be positive, and the angle will be between 0 degrees and 90 degrees. In the second quadrant, however, we go to the negative side of the x-axis or the cosine axis, and therefore the cosine will be negative, and along with it all other functions except the sine. So the value of the cosine will be between -1 and 0, while the sine will be between 0 and 1. The angles will be between 90 degrees and 180 degrees. In the third quadrant, however, we are in the negative parts of both the sine and cosine axis. Therefore, they will both be negative. However, in this case, the tangent and cotangent will become positive. That is because, if we recall the previous equations and we fill in with the cosine and sine, we will notice that the negative signs will cancel. So the values of the cosine and sine will be between -1 and 0, and the angle will be between 180 degrees and 270 degrees. Finally, the fourth quadrant, where only the cosine is positive, while the sine and all other functions are negative. Then the value of the sine will be between -1 and 0, while that of the cosine is between 0 and 1. The angles in this case are between 270 degrees and 360 degrees. We can, of course, move in the negative sense. Then, the boundaries for the fourth quadrant will be from -90 degrees to 0 degrees, and that of the third quadrant will be from -180 degrees to -90 degrees, and so on. Notice that in both the positive and the negative sense, when we state a boundary, the smaller angle is stated first. Now, to make it easier to remember, we can memorize a specific acronym, which is ASTC, which refers to All Students Take Chemistry. where A will refer to the first quadrant where all functions are positive. S refers to the second, where only sine is positive. D refers to the third quadrant, where only the tangent is positive, while C refers to the fourth quadrant, where only cosine is positive. On a side note, if you're having a hard time memorizing the formulas for trigonometric lines, you can also use the acronyms SO, K, and TUA. The first one refers to the equation of the sine, which is opposite over hypotenuse. The second one for cosine, which is adjacent over hypotenuse. Finally, tangent, which is opposite over adjacent. Back to our topic. We can also notice that the circle is divided into 4 semicircles, 2 of which determine the sine of the cosine, and 2 for the sine of the sine. This is all dependent on the axis. So, in the upper semicircle, the sine is positive, while in the lower, it's negative. In the right semicircle, the cosine is positive, however, on the left semicircle, the cosine is negative. Everything that has been stated facilitates the process of obtaining the exact coordinates of a point in a trigonometric circle, or the functions and their signs, depending on the given and required to prove. Believe it or not, trigonometry is used to facilitate a lot of processes and in a lot of professions. It is used in construction, flight engineering, physics, and in marine biology. It is also used in architecture. Let's say an architect would like to redesign a building, then he would use trigonometry. The architect would like to know the height of the building, and therefore he would take a point that forms a perpendicular line with the bottom of the building. He would then find the angle whose vertices will touch the bottom of the building and the top of the building. Now the architect can form a right triangle with these 3 points, and knowing the angle and the distance from the point he set to the building, he can calculate the tangent of the angle, and by substituting by the distance that he has, he can finally find the height of this building. This process can be used for multiple purposes, such as calculating the height of an object or finding its position with respect to another. Thank you for your attention. I hope this video was full of new and helpful information.